Welcome back, dear students. This is Ramana sir, Physics. How are you all? We are discussing long answer type questions in second year Physics. TS and AP intermediate long answer type questions we are discussing. So in the last two classes we discussed formation of stationary wave in string and open pipe, closed pipe. Now today we are discussing beats topic. We are going to discuss about beats topic. Here in this, the definition of beat. Beat means what? What are beats? The last question, what are beats? The derivation for beat frequency and uses of beats. Uses of beats also they'll ask. First of all, definition of beats. Beats means what? Here, observe here in this diagram, two waves are moving in same medium, same direction. That two waves should be slightly different frequencies. The two slightly different frequencies are moving in same medium, same direction. If they superimpose, what happens? Waxing and waning sounds are produced at regular interval of time. This phenomenon is called beats. One waxing and one waning produces one beat. Here beat frequency, the formula N1 differs N2, so that one we have to derive now. Here definition of beats is what? When two slightly different frequencies are moving in same medium, same direction, if they superimpose, what happens? Waxing and waning sounds are produced at regular interval of time. This phenomenon is called beats. One waxing and one waning produces one beat. Here you can observe the two waves are moving. So one blue wave is there, another one is black wave is there. So slightly different frequencies of sound waves moving. So that time here both the waves are in same phase. What happens? Resultant wave is maximum. If both are in opposite phase, resultant wave is minimum. Here also both are in opposite phase, minimum, and both are in same phase, maximum. So this process continues. The maxima, minima and maxima alternatively, maxima and minima alternatively form. The meaning is what? Waxing and waning sounds are produced at regular interval of time. So waxing and waning sounds are produced at regular interval of time. Here waxing means what? Maximum. Waxing means what? Maximum. And waning means what? Minimum. Waxing and waning sounds are produced at regular interval of time. Here the waves equations I am taking. The first wave equation I am taking S1 equal to A cos omega 1t taking, and S2 second wave displacement S2 I am taking A cos omega 2t. First wave displacement I am taking S1 equal to A cos omega 1t, and second wave displacement, so different frequency, that one slightly different frequency, that is why here omega 2 we taken, omega 1, omega 2. We know that here omega is what? Omega formula 2 pi n, we know that. Okay, why? Because here the omega 1, omega 2, why we taken? Here frequency is changing, so that is why omega 1, omega 2 we are taking. According to principle of superposition, the resultant displacement S equal to what? S1 plus S2. Resultant displacement S equal to S1 plus S2. Substitute the values. S value is what? A cos omega 1t plus A cos omega 2t. Here we can take A common. A you can take common. Cos omega 1t plus cos omega 2t. Here we know that this is like cos A plus cos B type is there. This is A, this is B. If you assume A, B, cos A plus cos B type is there. Cos A plus cos B formula is what? 2 cos A plus B by 2 cos A minus B by 2. I am taking here S equal to A as it is. Here 2 cos A minus B by 2, I am taking omega 1 minus omega 2 by 2 into this t I am taking, and cos A plus B by 2 omega 1 plus omega 2 by 2 into t I am taking, t taken common. Assume here omega 1 minus omega 2 by 2 is omega b, and another one cos omega 1 plus omega 2 by 2. Assume omega a. Observe here, therefore s equal to what we can take. These two I am writing outside. 2a cos omega b into t cos omega a into t, where omega b is what? Where omega b is equal to how much? Omega 1 minus omega 2 by 2, and omega a is what? Omega 1 plus omega 2 by 2, omega a, omega b. Here assume here 2a cos omega b t is resultant amplitude in this. What happened? This is like a, okay, cos omega t, the resultant amplitude cos omega t type is there. Here conditions for maxima and conditions for minima now we have to derive. Conditions for maxima is what? Conditions for minima is what? We'll derive now. Here conditions for maxima, omega value we know that is 2 pi n. Okay, so from cos omega 1 minus omega 2 by 2 into t is equal to, if maxima means we can take, so is equal to what? Plus or minus 1. Maximum is plus or minus 1. Here omega 1, what to do? 2 pi n. Omega is what? 2 pi n. Omega 1 means 2 pi n1 minus 2 pi n2 by 2 into t is equal to plus or minus 1. Here 2 pi you can take common. What happens? n1 minus n2 by 2 into t is equal to plus or minus 1. Here cos, in plus or minus 1 we are taking, when we will get plus or minus 1 in cos function, cos 0 value 1, cos 180 is minus 1. So like that, therefore 2 pi into n1 minus n2 by 2 into t is equal to n pi you can take. N pi you can take. Here n values are what? N values are 0, 1, 2 and so on. N values are 0, 1, 2 and so on. Here 2 pi, in this pi gets cancelled, 2 gets cancelled. n1 minus n2 into t equal to n. T equal to what happens? N by n1 minus n2. N by n minus n1 minus n2. Substitute once n value 0. 0 by something is what? 0 only. Next n value substitute 1. 1 by what happens? 1 by n1 minus n2. And 2 substitute 2 by n1 minus n2. And substitute 3 n1 minus n2 and so on. Here the difference is how much? The two successive, the time periods, the two successive maxima or minima. So what we'll get? Time interval between two maxima. The time interval between two maxima, how much we'll get? Here 1 by n1 minus n2 minus 0, that is 1 by n1 minus n2 only. 2 by n1 minus n2 minus 1 by n1 minus n2 is how much? 1 by n1 minus n2 only. Therefore, the time interval between two maxima, time interval between two maxima is how much? 1 by n1 minus n2. The meaning is what? The reciprocal of the time period is what? Frequency. Therefore, frequency is how much? N1 minus N2. Conditions for minima. Conditions for minima. In this, cos omega 1 minus omega 2 by 2 into t is equal to, here how much we have to take here? 0 we have to take here. So when we will get 0, cos pi by 2 time we will get 0 value. So that is why here in this omega 1 minus omega 2, same as it is 2 pi n1 minus 2 pi n2 by 2 into t is equal to, what is the condition? 2n plus 1 into pi by 2 is the condition. Why? Because if you substitute n value 0 here, so what happens? N value 0, if you substitute, what happens? Pi by 2. Cos pi by 2 value how much will get? 0 will get. Here 2n plus 1 into pi by 2. Here 2n plus 1 into pi by 2 taking. Cancelling here, pi cancel, and these two cancel. So that time what happened? The t equal to, what will get? T equal to 2n plus 1 into 2n plus 1 divided by 2 into n1 minus n2 will get. N1 minus n2 will get. Here the first one will get in this, what will get? Substitute the n value 0 first. What happened? Here 0 into 2 is 0. 1 by 2 into n1 minus n2. In this condition, substitute 0 value n equal to, what happens? 0 into something is 0. 1 by 2 into n1 minus n2. And here what will get here? Substitute n value 1. 2 into 1, 2 plus 1, 3. 3 divided by 2 into n1 minus n2, and odd numbers will get. If you substitute 2 value, what happened? 2 2 is 4 plus 1, 5 by, so as it is 2 into n1 minus n2. The differs how much? The time interval between two successive minima, 3 by 2 into n1 minus n2 minus 1 by 2 into n1 minus n2, how much? 1 by n1 minus n2 only. So that is why the time interval between two successive minima, how much? 1 by n1 minus n2 only. So it is very clear from both the cases, maxima and minima, it is very clear. The beat frequency is how much? There is how much? N equal to n1 differs n2. Here n1 value, n1 differs n2, that meaning n1 minus n2 or n2 minus n1. So this is the beat frequency formula. Applications or uses. They'll ask, what are the applications or uses? Uses of beats are what? They'll ask. Okay. So here the unknown tuning fork of frequency we can determine using the beat frequency or beat phenomenon, and to detect the dangerous gases in mines using beat phenomenon, and to produce special effects in cinematography also, and to tune musical instruments. So this beat phenomenon we can use. Finally they'll ask uses of beats. Okay, these uses you have to write. First definition of beats, then beat frequency derivation, then afterwards uses. Any 4 uses you have to write. Afterwards problem also chances are there, so I'll discuss now the numerical. First one, you can take 2 organ pipes of length 65 cm and 70 cm respectively are sounded simultaneously. How many beats per second will be produced between the fundamental frequencies of the 2 pipes? Within the bracket, velocity of sound is given, that is 330 meter per second. In this question they are asking number of beats produced for the 2 sound waves of lengths given time. Here first wave is given, how much given? The first length is given 65 centimeters given. So that meaning is what? 65 centimeter means 65 into 10 to the power of minus 2 meters, converting into SI unit. and at the same time L2 value also given. How much given? 70 centimeter. So that also I am converting 70 into 10 to the power of minus 2 meter. And within the bracket velocity of sound is given. How much given? 330 meter per second given. What they are asking? Number of beats produced per second. Number of beats produced per second is how much they are asking. Here number of beats produced per second means that meaning is what? Beat frequency. They are asking what? Beat frequency. How much they are asking? Beat frequency formula just now we derived. What is the formula? N equal to N1 minus N2. Here the two frequencies are in fundamental mode only. So that is why in the fundamental mode formula is what? V by 2L1. That is the first one, L1 we are taking, and V by 2L2. V by 2L1 and V by 2L2. Here N equal to, here V by 2 we can take common, 1 by L1 minus 1 by L2. Substitute the values. N equal to V. V value is how much? 330. 330 by 2 into 1 by L1. 1 by 65 into 10 to the power of minus 2 minus 1 by L2. L2 is how much? 70 into 10 to the power of minus 2. Here N equal to 2 1 ja, 2 1 ja, 2 6 ja 12 and 2 5 ja 165. Here this 10 power of minus 2 I am taking outside. Common I am taking. Remaining is what? 1 by 65 and minus 1 by 70. LCM you take, what happens? LCM time 70 minus 65 by 65 into 70. Here this 10 power of minus 2 sent to numerator, what happened? It becomes 10 power of plus 2. Here 70 minus 65, 5 divided by 65 into 70. Here 1 0 purpose, here 1 0 cancel. Here 5 table, 5 1 ja 5, here 5 1 ja, 5 3 ja 15, 13 7 ja. N equal to 165 into 13 7 ja, how much? 91. Solve this one. 17 point something you change you'll get, that is nothing but, therefore N equal to 18. Number of beats how many? 18 beats will be produced. Total number of beats are how many? 18 beats will produce. Next one you can take. A vertical tube is made to stand in water so that the water level can be adjusted. Sound waves of frequency 320 Hz are sent into the top the tube. If standing waves are produced at two successive water levels of 20 centimeters and 73 centimeters, what is the speed of sound waves in the air in the tube? In this, the frequency is given. How much given? 320 Hz, and the two lengths are given, L1 and L2, in centimeters given. Convert to meters. 20 into 10 to the power of minus 2 meters and 73 into 10 to the power of minus 2 meters. The velocity of sound wave is how much they are asking. What is the formula? 2n into L2 minus L1 can take. Here substitute the values. V equal to 2 into n value is how much? Frequency 320 and L2 minus L1, 73 into 10 to the power of minus 2 minus 20 into 10 to the power of minus 2. Here V equal to, multiply this one, how much? 640 into 73 minus 20, how much? 53 into 10 to the power of minus 2. Here 1 0 purpose, 1 minus cancel, more minus 1 is there. Here multiply this 53 into 64, so you will get 30, you will get in 10 power of minus 1 also there, you will get 339. Velocity units are what? Meter per second. So that is the answer, 339 meter per second. So this is the beats topic. The last question, what are beats? And for derivation, beat frequency derivation they'll ask. Then numericals are uses of, applications of beats or uses of beats they can ask. And one numerical also they can ask. The next class we will discuss the another most important topic. So if you understand, please like, share and subscribe the channel. Thank you for watching.